All right, good morning to statistics. So this is going to be your quiz review for quiz number 4, so we can have that. Let me go ahead and share my screen so we can kind of get started on what we're going to be working on. Okay. One thing I do want to kind of take a point to address before we get started with the rest of this is, we have our class Connect Math. You guys are well acquainted with that, but down here, video lecture collection. Like I've put a whole bunch of kind of like walkthroughs to. Oh, that's not the one I want. This is for pre-calculus. But you guys have a video lecture collection too in your class, and I think I've gotten up to about chapter 9 or something, but it pretty much walks you through a lot of the homework problems that we're going through. I know some people use this as like some kind of a weird ASMR thing to fall asleep to because I know I'm exciting, but if you need help with the homework, and I didn't do all the problems, but I do try to go through and do all of the at least representative problems. Okay, so if you're having a tough time with a homework problem, go down to the bottom here, look for video lecture collection, and there's lots of them. Okay, so again, just walking you through what's going on. All right, so with this one, what I'd like to talk to you about is I'd like to talk to you about what's going to be on the quiz. Okay, so I'm sorry for quiz 4 is I'm trying to mimic and marry the online class and the face-to-face class back together again, so you guys have a little bit of a lot of the stuff that we've quizzed on, we've kind of quizzed on before, so I apologize. This should be the last time that happens. But here we go. We have an expected value problem. We have a binomial problem. Okay, if you don't know how to use the calculator yet for this one, or you're more comfortable doing it by hand, I really urge you to do the binomial problem with the calculator on this one, because I stole it out of a textbook, and they did not care that you would have to do a dozen calculations per problem. Okay, they expected the calculator to be used. So since most of us are using that, I didn't feel like this was too much of a hardship. But in years past, there's no way I would have asked this problem, but things have changed. And then we have a normal distribution problem. Okay, and we have another normal distribution problem. Okay, so we have a 6.1, a 6.2, and a 7.2. Okay, 7.1, I did not ask you a question about 7.1. Okay, but you kind of need 7.1 to do 7.2. Okay, and the next one will be 7.2 and 7.3. Okay, I think. Yeah. So that's where we are. Okay, let me take a look at binomial distributions. Not binomial, expected value, because those, and I understand and I appreciate the fact that these can be a little tricky and setting them up can be a little tough. So my recommendation to you is, like, I set them up in a certain way. Not that it's the textbook way, but it's the way that makes sense to me, and I tend to not get wrong answers when I'm doing it. Okay, so that's my goal, is to set them up in a way to makes them easy to solve for me. Okay, so it says we have New York State Lottery's number you pay $3 and you can bet that the sum of the numbers add up to 13. That's great. We don't really care. The probability of winning is 0.07. That we care about. And if you win $3.50 or $7.50, which is a profit of $4.50. If you lose $3. Okay. What is the expected value of your profit? So we don't care about the New York Lottery Commission on this problem. We're caring about what's going in your pocket. Okay. So when I'm dealing with the lotto, okay, remember, it's the formula you have to know here. Okay, it's the sum of the value of event times the probability of the event. Okay, So we're going to add up the value of the events times the probabilities of the events. Okay, times comes first. Remember, order of operations, and then we add. Okay, so we have win and lose for our lotto numbers. Okay, if we win, right, what is our profit? Well, they told us. They said we have a profit of $4.50. Okay, so we are winning. That's $7.50 minus the $3 it cost us to get into it. So we're going to win $4.50. Okay, what's the probability of that happening? Okay, if we win, it's 0.07. Hooray! Okay, so here's our X. Here's our P of X. Some people like to do these horizontally. Some people like to do them vertically. That's all okay. Okay. And if we lose, what is our profit? Well, we're out $3. Okay. And with the probability of not winning, 0.93. Okay. And if you'll excuse me, I'm going to go fetch calculator. And all we're going to do, this is the reason I like to set them up this way, because I just have to multiply across. Okay. So we're going to have value of the event, 4.50, times the probability of the event, 0.07. Okay. And that is 0.315. All right. And next we have -3 times the value of the event, we're out $3, times 0.93. Okay, we get negative 2.97, 2.79. Okay, and then we're going to add these up. Okay, so we're going to say this is, okay, so we're going to add up, we're going to say negative 2.79 plus a positive 0.315. Okay, so our profit is negative 2.475, negative 2.475. Okay, a fair game is when the expected value for either side is 0. So expected value for the winner, the expected value for the player, the expected value for the house is 0. But the whole point of starting a lottery for the children is really to generate extra revenue for the state. So it's effectively a tax that you're volunteering for. Okay. And you know, if your thing is to, well, there's nothing wrong with gambling and playing a lottery and doing that. The problem is when it's uncontrolled. So if you want to spend, you know, I don't know what these things cost. You want to spend $15 every other week or something, like that's your paycheck and that's the small amount of joy you get in the week. Like there's nothing wrong with that. Okay. If you're spending enough tickets that you're like, well, if I don't make enough with this, then I'm not going to have a mortgage this month. Like that's not so good. So that's not a good situation. But people who have a controlled amount that they want to spend, it's, I'm going to spend this on gambling because I enjoy that. There's nothing wrong with it. Okay, but understand you're pretty much forking over $2.48 to the state every time you're playing. Okay. Now, nobody is actually forking over this amount of money, right? It costs you $3 to play, and if you win, you get this much money back. Okay, we get $7 back, but you get $4.50 plus. So be careful about saying for every time you spend a lotto ticket, you're giving the state $2.48. You kind of are, but only like in the really, really big picture. Okay, not any individuals doing this. All right. So let's see, we'll probably need to do at least one more. Okay, so this one, standardized test. You're trying to answer a multiple choice test on a standardized test. There are 5 choices. If you get the problem right, you get 1 point. If you get it wrong, you lose a half a point. Assume you have no idea, so you pick them at random. So throw a dart. All right, so what was our, so we have 2 events, right? We're going to assume that skipping it is getting the wrong answer. That's not true in every test. we're going to make the assumption that you're getting it wrong on this one. So you have to pick. Okay, so there are 5 choices. What's the probability we get a question right? This is 1 out of 5. Okay, so the probability that's going to happen, okay, here's our value. Right, and here's our probability. So we get a 1 out of 5, which is 0.2. For those of you who are worrying about the fractions, okay, honestly, I do recommend going back and trying to learn a little bit of fractions with it, because they are a really helpful way to explain things and to do things. And I guarantee you that whatever horrible thoughts and experience you had from Sister Mary Agony in the 5th grade or something, or 4th grade when you learned fractions, you can overcome all of that. Okay, you really can. It's going to take a little bit of practice, but it can be done. Okay, it might be a little embarrassing because, like, I don't want to read a 4th grade math book. Okay, I don't blame you, but sometimes you gotta pick the level that's going to work best for you. Okay, so what's my values? Right, if I get it right, we get a point. Hooray! And if we get it wrong, we lose half a point. So this is -1/2 or -0.5. By the way, for fractions, if you want to convert them to decimals, fourths, fifths, okay, tenths, halves, 20ths, those are all real safe to convert to a decimal. If you got to convert like 1/7 into a decimal, I guarantee you it's not going to work out so well. Okay, because of the weird rounding you have to put up with and everything else. Okay, so don't try to do this. By the way, let me show you a little trick. Okay, if I have 2/7 in your calculator, it's like, oh, I didn't want to put it into a I didn't want to put it into a decimal because that's going to mess me up. You go to math, the first thing up here is convert back to fraction. There. Now it's a far less painful experience. Okay, the calculator will convert this back into a fraction for us. So you might want to practice a little bit. By all means, if you know you're going to be doing math with the calculator and all of them, then yeah, use this. And once you're good at it, you can stop there. But I would really encourage you, like, go a little bit further. Okay, so I'm going to multiply these together. Okay, so 1 times 1/5, that is 1/5, right, or 0.2. Okay, and then -1/2. Okay, what's -1/2 times 4/5? So -0.5, -0.5. Okay, times, right, times 4/5 times 0.8. Oops, I don't want 2 multiplications there. I just want 0.8. All right. -0.5 times 0.8. I just want 4. Okay. But again, look, if you take the math, you change it back, you could get it back to a fraction if you wanted to. Okay. So this is going to be -0.40. Okay. So in this case, we have a -0.20, right? You have 20 cents, you spend 40 cents, you're in debt now 20 cents. So you really want to make sure you have, on this exam, you want to make sure that you're not guessing as much as you can. Of course, on any exam, you want to make sure you're not guessing, but, and since you don't have the option of opting out, this is kind of like you're screwed from the beginning. Okay, if you don't know what you're doing on this test, you're going to lose. So that's -1/5. Oh, they want 2 decimal places. Okay, -0.20. I'll do this because otherwise they'll yell at me. All right. Hooray. Well, you guys said, I see they're gonna be upset because I put the zeros at the end, but you said 2 decimal places, so what are you gonna do? Okay. So last one of these, investor is considering a startup company. She estimates 40% probability of a $20,000 loss, probability of 0.21 of a $14,000 profit, 0.14 $34,000 profit, and 25% of not making any money whatsoever. She breaks even though. Okay, what is the expected value of the profit? Okay, what would you expect the investor to make? Okay, so again, let's just set up our table. Okay, so we'll just go through the scenarios. I wouldn't know what to call these. I'm just going to call them outcome 1, 2, 3, 4, 5. Okay, and then we have a value of the event. That's what her profit's going to be, and a probability of that event. Okay, and we're just going to go here and say, well, screens are so tiny. Okay, so you have a 40% chance of a $20,000 $400 loss, $20,400 loss. So the value here is 20,400. Probability of this happening 0.40. Okay. Probability of 0.21 of a plus $14,000 500. Okay. A probability of 0.14. Okay, 0.14. Rumble. Okay, of $34,000. Okay, and a 25% chance of 0. Okay, and then you want to know about the investment. Okay, so all we're going to do here is multiply these guys together and then add them up. Okay, I'll do this one. It's the hard one. Okay, so we have $34,000. Okay, times 0.14. Okay, so this is 476L. Okay, we have 14,500 times 0.21. And this is 3,045. And then the last one is 0.4 times, you have to use this negative, you use the minus sign, it's not going to like it. But this is 20,400. Negative 816L. Then we add those up. Okay. So we'll say plus 3045 plus 476L. Okay, we get negative 355. So investing in this thing, overall, it's going to be a loss. I would not recommend somebody invested in this property. There's other considerations you might want to take into this. If you ever take a finance type of a class, one of the things you'll want to do is find the standard deviation of this, because that's going to kind of equivalent to your risk tolerance. Most people, some people have a high risk tolerance, some people have a low risk tolerance. It depends on age, gender, life outlook, things like that. But if you have a low, if you have a low risk tolerance, you will prefer lower standard deviations. Okay. All right. I don't want to spend too much time more on this one because this is, one question. All right. And we'll go off to other things. Okay. So 6.2, that's going to be binomial distribution. So we have one of those. Okay. If you don't mind, I'm going to pick one at random and not worry about working 3 or 4 of them. The reason I did the expected values because they could be they could be kind of rough. All right, I don't want to pick that one because I didn't like that because the wording was a little bit weird. I think I did this one as an example previous. This isn't too bad. This one works. Okay, we can all relate. Okay, in a poll, 65% of respondents said that their jobs were sometimes or always stressful. 11 workers were chosen at random. Okay, so we have N is equal to 11. Okay, we have a probability of 65%. Okay, that's it. All right, so it's either stressful, not stressful. So we have two outcomes. So on this problem, one of the most important things is diagnosing this problem. Like, what technique do they want me to do if you don't know you're in chapter 6? Did they say anything about a mean? No. Did they say anything about a standard deviation? No. Did they want the expected number of workers or anything like that? No. They just said, what's the probabilities? And what did they give us? They gave us a number and a probability that it's going to be the one that they're looking for. That's it. That's how you tell this thing is binomial. They didn't say anything else about anything else. Okay. So what we're going to do here is we're going to say, okay, well, we have N is equal to 11, probability of success, part A. What is the probability that 10 of them find their job stressful? So we're going to do binom PDF because we want a particular value. They said exactly 10. So we have a total number, okay? We have 0.65, that's probability of success, okay? And then 10, okay? So we're going to go to distributions. We're going to say we need to go to binomial PDF. Okay. We're going to do 11. Oops, I want 11, comma, 0.65. Wow, that's a lot of commas. We have 11.65. Okay. Comma. Right. So we get 2.02. 0.02335. I'm going to go to 4 decimal places, always 4 decimal places, 2, 3, 4. Okay, 0.0234. Okay. More than 8. What numbers are more than 8? 9. 9 is more than 8. So we want 9, 10, or 11. Okay. Now we could do a binomial PDF on each one of these. Okay. And then add them up, and that would be fine. All right. But what we're going to do is we're going to do binom CDF. Okay. And this is the hardest one. They want more than 8. What numbers are more than 8? 9. Okay. Binomial CDF counts from 0, 1, 2, up to a certain number. If they wanted more than 8, we're plugging in 8 here because we're going to subtract this off. Okay, when it says more than, we're subtracting it off. So it's 1 minus binom CDF. There's 11.65, and we're going up to 8. Okay, and that's how we're doing that. Okay, on quiz 4, that was probably the most missed thing, is people had a hard time with this. Okay, 1 minus distributions. We're going to go to PDF, binom PDF. There we go. Okay, oh, CDF rather, CDF. Okay, and we're going to go with 11.65, is it? 0.65, and up to 8. Okay. So we end up with about 20%, 0.2001. Oh, we're not done yet. Okay. What is the probability that fewer than 4 find the job stressful? Okay. What numbers are fewer than 4? 0, 1, 2, 3. Now, if you tell your child, you know, look, you're going to have to pick fewer than 4 toys to bring with you. Okay. You say, I only want 1. That's fine. But the maximum you're going to allow, right? You said fewer than 4, they're going to say 3. You probably wouldn't speak to your child that way, but say 3 or less, but fewer than 4 is equivalent. So in this case, it's not more than just binomial CDF. We have 11.65, and we're going to go up to 3. That's what we want. Okay. So we're going to go with second function distribution. Again, we're going to go to binom CDF. Right, we have 11. Always keep the scenarios the same, and then up to 3, fewer than 4. Right, so 0.0112, 0.0112, 1, 2, 3, 4, or 122. Sorry, 122. Okay, 122. Okay, so this is 0.0122. Okay, would it be unusual if fewer than 6 found the job stressful? Okay, remember the cutoff for unusual is 0.05, so they want fewer than 6. What numbers are fewer than 6? 0, 1, 2, 3, 4, 5. Is 6 fewer than 6? No. So those are the numbers we want. Okay, so we're going to do binom 11.65, and that's going to be up to 5. Okay, and we're just going to plug that in. And here we go. Distribution binom CDF, because we want a collection, and we have 11.65 comma 5. Right. We end up with 0.1487, right? Because that 8 rounds 6 to a 7. Okay, 0.014. Oh, and this is not unusual. Okay, for it to be unusual, it has to be less than 5%. So this one, fewer than 4, that's unusual. Fewer than 6, not so much. This would not be unusual. Probability is 0.1487. 0.1487. Okay, double check. 122. Okay, we're pretty happy. Oh, try again. Didn't like it. Exactly 10 of them. What did I do wrong? Let's see here. Second function distribution, particular. Okay, we have 11 people. We have 0.65, 0.65, 0.65, and then 10. Right. Okay, well, I don't know what I typed in then. But whatever it wasn't right. This is also why I really encourage you guys to write down this whole thing. So I really like to see what you've entered into the calculator. It helps when I grade to know what you meant versus what you wrote, what you put in the calculator. So yeah. So what is this? This was 0.0518. 0518. Let me try again. All right, then they're happy. Okay, so binomial, it really is that straightforward. Okay, we'll go with that. Okay, now I'm going to hit 7.2 lectures. Okay, previous. Okay, I think we could say something like this too. You have to watch the video this far in order to get this, but you'll notice I changed all the due dates to the end of the semester so that you would have the freedom of going back and working on some of them. You wouldn't have to get them all done right now, and you have that flexibility. Okay, so I hope that helps a little bit. All right. So let's see if we can find anything. I like 6. Okay, we'll do 4 and perhaps 6. Okay, So again, all these problems are very similar to each other. If you can do them on one, you can do them on. You have to use a calculator to do these because there just simply isn't a mathematical way to do this numeric. Well, there is, but it's going to take a long, long time to do it numerically. You don't want to do this by hand. Okay. So Centers for Disease Control and Prevention reported that diastolic blood pressures of adult women are approximately right here. When you see this word, approximately normally distributed, you know you're in a chapter 7 problem at that point. You know you're going to be working with the normal distribution. They gave us a mean, they gave us a standard deviation. Okay, so we know normal distribution, approximately. We have a mean, we have a standard deviation. Okay, so 80.1, 80.1, 9.9. Okay. What proportion of women have blood pressures lower than 71? So we're going to go with norm distribution, the norm CDF rather. We never use PDF for this one, okay? Because it's going to tell you the Y value of the graph. We don't care. We want the cumulative value. Let's see, norm PDF, CDF rather. Excuse me. And we need a low, a high, a mean, and a standard deviation. Okay, so let's look at what we're doing. Proportion of women that are lower than 71. Okay, here's our normal distribution, approximately. Okay, it's going to be about here, right? This one is 80. This is going to be 80.1 rather, and this is going to be 71. We're looking for all of this, okay, lower than this part. So the low value is like down here at negative infinity, and the high value is going to be 71. So what I want you to do is, considering the mean is about 80 and the standard deviation is about 10, we need to find a ridiculously low blood pressure for this. If you want to use -1 EE99, that's fine, but you're going to get the same answer if you use something just low. Okay, so I'm going to do norm CDF, which is ridiculously low blood pressure, 0. Guarantee you, people with 0 blood pressure have bigger issues than hypertension. Okay, we're going to go up to 71. Okay, now we have 80.1 and 9.9. Okay, so we get a calculator. Okay, so distribution, norm CDF. Okay, and we're going to go from 0 up to 71 with an 80.1 mean and a 9.9 standard deviation. Okay, boom, 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 done. Okay, and we get 0.178, and it's 99. So we're going to go to 4 decimal places. So that's going to turn this 9 into a 10. So 0.179 out. Okay, that's our answer for that one. Okay, again, I don't really care about the trailing zeros either, but again, generally you want your answers, if it's a probability, it's 4 decimal places. Okay. Oh, you get to check an answer. Good. Hooray. I know. Proportion of women who have blood pressure between 72 and 90. 92 rather. So when we do our norm CDF, right, we want the low number, that was 72. The high number, that was 92. Same mean, same standard deviation for the whole problem. Okay. And now we're just going to go back here and say distribution, CDF. Okay. 172, high number 92. Okay. 80.1. Okay. And 9.9. Okay, so as you are studying these, okay, if you are using the show me a hint button or do this one for me or show me an example, you don't know it yet. Okay, you really need to do like 3 of these without looking at anything, with enough time in between the last time you looked at them so that you know that you have this. Okay, that works for all the problems you're going to do. Like study the expected value today, study the binomial. Tomorrow, do 3 problems of expected value, do 3 problems of binomial without looking at anything. If you have to, then you have to put a little star next to it and say, I don't know this yet. We're going to do 3 of these tomorrow. Okay, and so forth. Okay. And then when you're studying tomorrow, you do your little quiz yourself, okay, and then say, okay, I'm going to do a couple of normal distribution problems. And if you have to look at them, then that's fine because you're learning them. But the day after, you're going to pick 3 and you say, I do these without help. And if you have to look, then you're doing it again. Maybe 3 days later, once you have all of them, like you say, I got these. Try making like do 2 of each. Okay, do 2 of each problem and test yourself to see whether or not you can do it. Testing yourself is the most effective way to study. Okay, the med schools are the ones that did this research because they want people to pass their classes. They're paying an awful lot of money to do that. They don't want dropouts. Okay, so this is 0.6787. Okay, they want to be paid. So as you're going through and doing these, testing yourself to make sure you're getting them right, that is the best, that is the single best way to study. Okay, try to spread it out. Okay, people who spread out their studying have they have an expected 10% higher on an exam or on a quiz than people who cram it all in one night. So if you could do it for a whole week, do it for 5 days, whatever, you're going to do 10% better. And this is not unique to math classes. Okay, this is all of your classes. Okay, so if you can afford to do that, you should do that. Okay, so this one, okay, same. Notice, well, not quite the same, right? It's 80.5 instead of 80.1, so you know where the randomization is. This is our mean. This is our standard deviation. Okay, so this is find the 20th percentile. Notice how this is a different wording. Okay, they give us a percentile and they say, tell me the blood pressure that leads to this percentile. In the previous problem, it was, here's a blood pressure, what percentage fall under this, or what percentage fall over this. Okay, and by the way, if you need a higher probability, if you need the probability on the right side of the curve, like what if I wanted the probability of blood pressure greater than or equal to 90? We go up here to 90, pick a ridiculous number for a high blood pressure. Okay, again, you have a blood pressure of 1,000. I think you probably have some bigger problems than worrying about this. Okay, I don't even know if that's possible. If you have a blood pressure of 1,000, you probably would have popped. Okay, so there we go. So we're going to do second function distribution. This is because they're asking us for a probability, or give us a probability first. We want norm inverse. Okay, we're going to do 0.20 and then mean, which is 80.5, and standard deviation 9.9. Okay, and inverse norm goes from, this blood pressure would be what did they say, 72.2. Okay, you can go like 1 decimal place after, but look at what they did for us. They said 80.5. I don't want to give you blood pressure past what you've already measured. You've told me you can't measure it into the second decimal, or you don't care to measure it to the second decimal. So I'm only going to report back to you however many decimals they've asked about. Okay. Generally, if they don't say, it's 2. Okay. 2 decimal places. Okay, but if they don't say, rule of thumb, it's 2. All right. Probabilities, 4 decimal places. Okay. Values, blood pressure values, tree heights, chicken weights, 2 decimals. Okay. So this will be 72.2. And then we're just going to go through all of this. What if they wanted something like they want the upper 10%? Okay. We can't do upper because again, normal distribute inverse normal, it does from negative infinity up to where you said. So if I want the upper 10%, well, what percentile is that? Well, that's 100 minus 10. That's the upper 10% would be the same as the 90th percentile. So we're going to crawl all the way up here. This is going to be 0.9. Okay. So we would have to do norm inverse or inverse norm. I never remember 0.9. Okay. And then the mean and the standard deviation 80.5 and 9.9. Okay. So that's the kind of thing you're going to do. Again, plugging it into the computer is not too bad. This is not the answer to a particular question, but inverse norm, you were given a probability. They want to know what blood pressure, what weights, what heights, whatever led to that particular percentile. What value would your X have? 8.5 and 9.9. Okay, so now blood pressure of 93 will be in the upper percentile for this. I think diastolic, I think that's the lower one, but I'm not sure. Okay, but that would be pretty high. Okay, so that's the kind of questions I'm going to ask you to do. Okay, study, like I said at the beginning, you know, I put on a whole bunch of class lecture videos, so you could watch this as you're doing your homeworks if you want to do specific ones. But you know, when you're studying, take some time to test yourself to make sure that you're doing it correctly. Okay, just rereading notes, rewatching videos. First time, second time, great. After that, it ain't helping. Okay, you got to practice and you got to do this. Okay. When I was in high school, I was in marching band. I mean, a big surprise. But it was good. It taught you how to study because I was a saxophone player. It was very competitive, and they would line us up. If you're a freshman or a sophomore, they'd line you up and they'd say, "Okay, school fight song. I want you to play from where it says D to E. Play it." And there would be like 20 kids watching you. You're like, "Oh, that wasn't very good. Go stand over there." Well, they use harsher language. Next, play it. That was good. Stand over there. Next one, do the same thing. And they do it through the entire section. All the freshmen, all the sophomores would have to do it. And then they turn around and they'd say, "Okay, first guy over here. Okay, let's see if you got any better. Play it." And it's like, "We're not leaving until all of you can play from D to E perfectly." And they were not. They were not kind. Okay, but it did get you used to like performing under stress. Okay, and performing like in a test type environment. So I urge you, test yourself, make yourself under stress. To do this, it's going to go a lot better for you. Okay, and again, that works for all of your classes. Okay, you got a history class, you got a bunch of multiple choice questions. Make little note cards for yourself. Ask yourself. Make sure you're getting them right. Flip them over, and then just leave that pile. When you're done, put them onto the side. But every once in a while, shuffle some of that stuff back in because you forget. So that'll do really well for like all of your classes. Okay, so please quiz yourselves. Okay, so thank you for showing up for the test quiz review. I wish you the best of luck. If you have questions, please let me know, and there'll be more in the announcements. Okay, thank you.